The Large Hadron Collider is exciting physicists once again with a strange new bump that's being found in some of its data. As you may know, the Large Hadron Collider is a massive experiment used to probe the very small scales of our universe by colliding subatomic particles together at very, very high energies. By colliding these particles together, physicists can examine what goes on in the collision and look at what other particles are made from that collision. But with just the data, you wouldn't have a hope of understanding what was going on. You need a theory to explain what's happening. And for a particle physicist, that's the standard model of particle physics. This theory does an exceptional job at explaining lots of things that we've seen happening in nature, which is why it's such a surprise for physicists that we may be seeing something which isn't predicted by the standard model of particle physics. Although this bump exists in some of the data, physicists aren't happy to say that a new particle exists just yet. The bump in the data occurs at 750 giga-electron-volts, where there are more photons than what the standard model would predict. But there isn't enough measurements at the moment for physicists to conclude that there is a new heavy particle out there. To give you an example of what a physicist is happy with to detect a new particle, it took 20 trillion proton-to-proton collisions for the Higgs boson to finally be accepted. All of these collisions produced tens of thousands of high-energy photons. Only 1,200 of them had the same energy as what the Higgs boson was predicted to have. And again, by analysing all these different 1,200 high-energy photons, they found that 100 of them came from a Higgs boson. So you need an enormous amount of data before you can work out the statistics and find out if a particle is actually there. Now, it doesn't help that the high energy of 750 giga-electron-volts, where this bump was found, is close to the limit of the detectors. This makes it ambiguous as to whether it's just a statistical error coming through in the data. But the fact that two separate experiments at the LHC have found the same bump suggests that there could be something there and not just a statistical anomaly. Going forward into the future, the Large Hadron Collider will continue its runs and will collect an enormous amount of data, which will hopefully shed some more light on whether this bump is real or just some statistical anomaly, some fluke in the system. Although the existence of this bump is still under investigation, there is speculation that it might be a heavier type of Higgs boson. Now, the Higgs boson has an energy of 125 giga-electron-volts, but this new bump has a new energy of 750 giga-electron-volts, which would make it a significantly heavier counterpart to the Higgs boson. The idea of particles having a heavier counterpart isn't foreign to nature. Take the electron, for example. It has two heavier cousins, the muon and the tau, which share almost identical properties except for their mass, with the muon being heavier than the electron and the tau being heavier than the muon. Whether or not this bump in the Large Hadron Collider's data proves to be a heavy particle or not will be determined in the future once a lot more experiments have been conducted and an enormous amount of data has been gathered and analysed. But it will be certainly interesting to see if it is a heavy new particle, how we can incorporate it into the standard model, to better the model and further our understanding of the subatomic world and of the universe. So I'm looking forward to whatever science comes out of the Large Hadron Collider next, because it could be something completely unexpected, like a little bump appearing on the data.